Hello everyone. In this lecture, we will continue to study the Basic Knowledge module. Today, we will study Lesson 2, Classification of Signal. There are many ways to classify signal. We can classify signal from different aspects. For example, it can be classified according to extra use or according to the time characteristics of the signal. According to the actual use, signal can be classified into television signal, radar signal, control signal, communication signal, broadcast signal, and so on. Well, according to the time characteristics, signal can be classified into deterministic and random signal, periodic and non-periodic signal, continuous and discrete signal, analog signal, sampling signal, digital signal, one-dimensional signal and multidimensional signal, causal and non-causal signal, energy and power signal. First, let's look at the determinist and the random signal. The determinist signal, if the signal changes with time, it follows a certain rule. It can be expressed with a certain mathematical function. For any certain moment, the signal has a certain function value. This value is called a deterministic signal, such as the sine signal. Let's study the random signal. If the signal value changes randomly at different times, it is impossible to exactly know in advance how it changes, so we call it uncertainty signal or random signal, such as the noise signal in the communication system. Let's move on to periodic and non-periodic signal. Periodic signal refers to signal repeatedly changing according to the same pattern at regular intervals. It can be divided into sinusoidal signal and complex periodic signal. Sinusoidal signal generally refers to simple harmonic signal. Complex periodic signal refers to periodic signal other than simple harmonic signal, while non-periodic signal is not periodic. The next part, continuous and discrete signal, which is the focus of this course. First, let's move on to the continuous time signal. Continuous time signal refers to the signal that is defined at any time within the existing time range, namely, it has certain function values with finite discontinuities. Generally, t represents continuous time variable. In particular, here the continuous means continuous time. Function values can be continuous or not. Figure 1 shows a graphical representation of a continuous signal. As for the discrete time signal, it only gives function values at some discrete instants. It is not defined at other times. It should be noted that here discrete means discrete in time. In general, tk is used to represent discrete time variable. The time interval tk equals to tk plus 1 minus tk, which can be a constant or can vary with k. We only discuss the case where t is a constant, so we use k to represent discrete variable. Discrete time signal can also be considered as a set of sequence values. Figure 2 shows a graphical description of a discrete time signal. Next, let's learn analog signal. Analog signal refers to a signal with continuous time and amplitude. Well, what is sampling signal? If you use the sampling pulse to get a series of discrete sample values from the continuous time signal, the discrete signal obtained is called a sampling signal or sampled signal. The discrete signal obtained is called a sampling signal or sampled signal, and this process is called signal sampling. Figure 3 shows an analog signal. Figure 4 shows its sampling signal. And what is digital signal? Digital signal refers to a signal with discrete time and amplitude. It is usually generated by quantitating and encoding the sampled signal. Figure 5 shows the digital signal of Figure 4, which is formed after quantitating and encoding. This course focuses on deterministic signal. We first learn continuous signal, then discrete signal. And we first learn periodic signal, then non-periodic signal. Now, let's take a look at Figure 6, 7, and 8. According to the definition of continuous signal, obviously, Figure 6 shows a continuous signal, Figure 7 shows a discrete signal, and Figure 8 shows a digital signal, and digital signal must also be a discrete signal. The fifth part, one-dimensional signal and multi-dimensional signal. One-dimensional signal is described by only one independent variable, such as voice signal. In this course, we mainly focus on one-dimensional signal. Multi-dimensional signal is described by multi-independent variables, like multi-dimensional functions in mathematics, such as image signal, and so on. Next, causal and non-causal signal. In terms of time variable, the signal ft equals to 0 when t is less than 0. The signal is called causal signal or starting signal. In other words, when t is less than 0, the value of signal ft is 0. Otherwise, it is called a non-causal signal. In engineering, signals are all causal. Only causal signals are physically achievable. Next, energy signal and power signal. In circuit theory, in order to know the characteristics of energy or power of a signal, we often analyze the energy or power of the signal on unit resistance, which is called normalized energy or power. Signal energy refers to the integral of the square of the absolute value of signal, as shown in Formula 1. While average power is expressed by Formula 2. It is the average of the signal energy. As for the definition of energy signal, if the energy of the signal ft is finite and its average is 0, the signal is called finite energy signal or energy signal. What is power signal? If the power of signal ft is finite and at this time its energy is infinite, the signal is called finite power signal or power signal. In actual engineering, some signals are neither energy signal nor power signal. To sum up, this class we have learned the classification of signal from two aspects. First, according to extra use, signal can be divided into television signal, radar signal, control signal, communication signal, broadcast signal, and so on. Second, according to the time characteristics, signal can be divided into deterministic and random signal, periodic and non-periodic signal, continuous and discrete signal, analog signal, sampling signal, and digital signal, one-dimensional signal and multi-dimensional signal, causal and non-causal signal, energy signal, and power signal. I hope you can master their definitions and their natures. This class is over. Thanks for your attention. Goodbye.